This is Kevin with Noble IT here, bringing you a video. Today we'll be talking about DMVPN, which is Dynamic Multipoint Virtual Private Network. We're going to be talking about the different phases of DMVPN, and we're actually going to be configuring all phases of DMVPN here. So this will probably be a 2-3 step video here. But yeah, I'm going to be explaining some of the concepts to it. The differences between phase 1, 2, and 3. Fairly simple once you kind of understand it. And we will be, just for this purpose here, we won't be protecting it with IPsec. We'll just set up the phase tunnels. And I'll probably set up another video that does that. But yeah, as part of my channel, it's no bull. This is straight IT, straight configuration, straight explaining what's going on. So without further ado, let's get into it. Let me explain the topology that I have here. We have our hub router right here. We have our ISP router simulating the ISP network. Won't be much configurations done here once it gets up and going. We have spoke 1 and spoke 2. So DMVPN phase 1 is a spoke to hub, hub to spoke configuration. So what I mean by that is all the traffic, whenever we want to communicate with spoke 2 from spoke 1, all the traffic is going to traverse the hub router always before it goes to spoke 2. There will not be a tunnel, a dynamic tunnel that establishes from spoke 1 to spoke 2 just yet. In phase 1, that is where phase 2 comes into play. So yeah, it's really kind of like a point-to-point, spoke 1 to hub, and then if you want the traffic to go to spoke 2, it'll traverses the hub, and we'll verify that as well. But yeah, so let's start with our tasks. We have a phase 1 lab task: establish the underlay routing with RIP for reachability. Right. So the reason we need reachability is because we're going to create tunnel interfaces, GRE tunnels. And for those to be up and operational, they need a tunnel destination, which is the physical IP address. So we need to be able to reach what we want to tunnel to. So let's start on spoke 1 here. Let's do a quick ping test of 10.10.10.1. Okay, this is the hub physical IP address here, 10.10.10.1. Can we ping it? No. And that's going to be the same thing for spoke 2. So we don't have that connection yet, right? So I'm going to do a show IP interface brief. These are my interfaces. This is my LAN here. So let's configure router RIP. We're going to do version 2. Network is going to be 20.20.20.0. Now this, basically what's going on is I'm putting this physical network here, 20.20.20.0 in RIP. I'm not going to put 192.168.20.0 because that is gonna, I want to advertise this in my overlay network with EIGRP, okay? Not with RIP, because then you can have some recursive routing and that won't be good. So that'll take care of spoke 1. Just do the network 20.20.20. Now we'll go over to spoke 2. Here we have spoke 2. And we're going to do the same thing, router RIP version 2 network. You can see here we want the 30.30.30 network. That'll take care of the spoke 2. Now we'll go to the hub route. We'll do the same thing, router RIP version 2 network of 10.10.10.0. That takes care of that. And then also we need to go into our ISP router, which is here. We'll do router RIP version 2 network. For this one, we have to do all 3 physical networks. Do 30.30.30.0. And this last one here is 10.10.10. All right, that takes care of the underlay. Let's do a little test here. We're going to log into spoke 1. I always like verifying. Verifying is good. We'll do a show IP route. Here we go. We see the 10.0 network. Forgot summary, but let's see if we can ping the hub IP address here. So that's good to go. Let's see if we can ping the 30.30.1. We can ping here. That's good to go. So we can go ahead and start with our configurations on the hub and the spokes here. So task 1 is complete. Now, before I create my tunnels, I want to go ahead and create my router EIGRP. So we're going to use EIGRP as our routing protocol for the overlay, right? So once, what it looks like is we have the underlay, which is this physical connectivity with RIP. Once we create a tunnel from the spoke to the hub, we'll have that tunnel, and then we want that neighborship to be with EIGRP, and then we want to advertise spoke 1's local area network, and then the hub's local area network, and so on and so forth, and we'll do that with EIGRP. But I'm going to configure this already. That way it can show you in real time what happens. So router EIGRP1, do a network of 192.168.20.0. That so our GRE network space is going to be 172.16.10.0. So we're advertising our local area network. Now I'm going to create the tunnel interface on this spoke. Okay. Interface tunnel 0. We're going to give this an IP address of 172.16.10.2 because our hub is going to be 1, spoke 1 is going to be .2, spoke 3 is going to be .3. So our tunnel has an IP address. Tunnel needs a source. The source is going to be Ethernet 00, which is our physical interface there. Our tunnel destination for phase 1 is going to be 10.10.10.1. This is going to be our physical IP address of the hub. You can see the tunnel comes up. We're going to do an IPMTU of 1400. IP TCP adjust maximum segment size of 1360. And then we're going to do, I'm just going to leave it at that for now, just to show you all. Now, router EIGRP1. Now I'm going to advertise the, oops, it's not OSPF. Now I'm advertising the IP address of that tunnel in EIGRP. You see here, those are my network statements. So that takes care of spoke 1. Not fully, but I want to hop onto the hub router. That way you can see some logs from the hub router. So I'm going to do interface tunnel 0. I'll do this in reverse order. IP address is going to be 192.16.10.1. Shut tunnel source. This one's going to be Ethernet 00. Now on the hub, what's different than the spoke, you're not going to put a tunnel destination on this, right? Because you'd have to you can only put one tunnel destination on it. So we don't use that. We use tunnel mode GRE multipoint. And it comes up. So now we are going to do IPMTU 1400, IP adjust maximum 1360. No IP split horizon EIGRP1. No IP next hop self EIGRP1. And I'm just going to leave it at that for now. Router, then we're going to create router EIGRP. If I can spell network. We're going to advertise our LAN here. We're also going to advertise our GRE tunnel. We should see neighborships come up on our hub router. Now let me show you something really quick. We see the adjacency on the hub router. Tunnels up new adjacency. Now I don't see it on the spoke. Why is that? Now, one thing that you have to remind yourself, if this was a regular GRE tunnel point to point, tunnel destination to tunnel destination, it would have come up already. But we have to finish the whole configuration for DMVPN. That way we can establish the adjacency. Okay, so on the hub router, we are going to go back to interface tunnel 0. And we'll do a do show run on that tunnel. This is what we have currently. We're going to add the next step of commands. So once we're here, we're going to do IP next hop resolution protocol, which it uses. You can see multiple commands here. We're going to do a network ID of 1, IP NHRP authentication. You can do an authentication key. This is optional, of course. We'll do Cisco 123. I was going to do authentication, but we'll just keep it simple. So did the network ID. We'll do tunnel key. For the tunnel key, I'll put 123. Do IP NHRP map multicast dynamic. And as you can see on the dynamic command, it says dynamically learn destinations from client registrations on hub. Okay. This is one of those things where it's different from the spokes. This is going to map multicast dynamic kind of automatically. I didn't want to say dynamically again, but so there we have that. We've done the IPU, IPTCP adjust maximum segment size. So let's take a look at it. Here we have IP NHRP network ID, tunnel mode GRE, and then map multicast dynamic. Did that one not take? I guess it doesn't. Okay, that's new. So this tunnel is now configured correctly. Let's go on spoke 1 and do the same thing. IP NHRP network ID 1, IP NHRP next hop server. Now, I do want to say that there's 2 ways for the spokes to configure the next hop server. This can be done with commands, with a 1-line command and then a multiple line commands. And I'll show you here both ways. We can do the 1-line command, which I like doing, is IP NHRP next hop server. We're going to put the IP of the next hop server. Now it says protocol IP of the next hop server. So this is going to be the GRE IP address, so 170 of the hub, 172.16.10.1 question mark. Then we're going to put, you see it shows and non-broadcast multiple access of next hop server. So we'll do NBMA. Now this is going to be the physical IP address of the hub, which is 10.10.1, right? As you can see here, this is the NBMA address. Okay. Now, if we do a question mark, we're going to apply multicast to it. That is the 1-liner, okay? That's the 1-liner that takes care of specifying the next hop server, and then doing the mapping of the GRE IP address to the non-broadcast IP address. And then on spoke 2, I'll show you that the 3-liner. Yeah, so let's see here. We do the tunnel key 1, 2, 3. We have it mapped. Oh yeah, as soon as I put in that tunnel key, you can see that the adjacency came up. So don't fret if you don't see the adjacency come up immediately. If you put in all the commands, just make sure that you're not missing a command, and you'll be able to see that. So spoke 1 just came up. I'm going to go ahead and do the same configuration on spoke 2 here. And then I'll show you that 3-lined command to do the same thing. Let's see what we got here. Do show run section, EIGRP. Do we have anything configured? Okay, no. So we have RIP, so we'll do router, EIGRP1, network 172.16.10.0. I will speed a little bit through this. This is the LAN, so that takes care of EIGRP. Interface tunnel 0, IP address of 172.16.10.3. This is our GRE space. Now again, tunnel source is going to be Ethernet 00. Tunnel destination, since it's phase 1, is going to be the NBMA of the hub, which is 10.10.1. IPMTU is going to be 1400. IPTCP, adjust segment size for 1360. IP NHRP network ID of 1, tunnel key 123, IP NHRP. Now this is the 3-liner that we're talking about here. The 1-liner would be to start off with next hop server, right? So the 3-liner, I like to start with make sure we specify the next hop server. So what is the next hop server, right? It's saying what's the protocol IP of the next hop server? That is going to be the GRE IP of the hub. Boom. That's one line. IP NHRP next hop server 172.16.10.1. You see our tunnel adjacency already came up, and I haven't even finished with the other commands. Okay. So with that, we do NHRP map. Then we're going to do IP address of destination. So that is going to be 10.10.10.1. Oh, I'm sorry. Map 172.16.10.10.1. And then IP address, IP NBMA. I do believe I'm missing something. Map multicast. Table 19.5. Oh, sorry. That is it is IP NHRP map 172.16.10.1 to 10.10.10.1. It is that command. And then IP NHRP map multicast, which is 10.10.10.1. You can see here what is the IP of the NBMA address. 10.10.1. So it is those commands right there. It is, like I said, I start off with the next hop server. To memorize, I say, okay, what's the next hop server? I know this is going to be the GRE IP. Now it's, okay, I'm mapping the GRE IP to the NBMA IP. And then the third command is NHRP map multicast 10.10.10.1. So let's check if we have neighborship. We do. We'll do a little verification commands first, and then I'll do a trace route. So this concludes our phase 1 configuration. We'll do some verification. First command is show DMVPN. So you see here, it shows our peer entry number 1, peer NBMA address. So our 10.10.1 is our physical IP address here of the hub route, and the tunnel address of our peer is 172.16.10.1, which is that GRE space that's up here. So that's that tunnel IP. State is up. It's been up for 2 minutes and change. Attribute being S static. Okay, we did not learn this dynamically. Right, we manually inputted this. Now, if we look at the hub route, do the same thing. Show DMVPN. Do you see the difference here? We got 2 peers, our spokes, but their attributes are dynamically learned. Why are they dynamic? Because we specified in the commands map multicast dynamic for the hub. That command was interface IP NHRP map multicast dynamic. Dynamically learn destinations from client registrations on hub. That's why this shows that dynamic. So that takes care of those commands. Another one is show NHRP. Show NHRP. No, it's not show NHRP. Did I do show DMVPN already? Oh, ridiculous. Show IP NHRP. Right, if you do just the regular show IP NHRP, it gives you some information. Now, I'm not a big fan of this command. I like to do a little bit more. You can do the brief command. This shows you the tunnel 0 interface, next hop address and the target network, and then the NBMA address. There's also a summary command. You have 1 static. Then you have the detail command. So there's definitely some commands there that can help you identify everything else. Now we have the verification commands, but let's look at the traffic flow. We'll do on this PC1, we'll do a trace route. Okay, so this is my PC1 here. Let's just do a normal ping. Oh, let's do a trace route to 192.168.30.10. Is this our 30.10? Okay. Does trace route not work? Or is it just trace? Huh. Look at me. So this is how it looks when we do a trace route to 192.168.30.10 from PC1 to PC2. Alright. It shows that it hits 192.168.20.1. This is our gateway. 172.16.10.1, which is our hub router's GRE interface. Then it hits 172.16.10.3, which is spoke 2's GRE interface. Then it goes to 30.10, which is this PC here. If I do that again, it's always going to be that same traffic flow. It's never going to directly go from spoke 1 to spoke 2, and that is what phase 2 and phase 3 allow. So this is always going to be the same traffic flow. If the hub is down, the communication won't be there from spoke to spoke. So thanks for watching. This is phase 1 DMVPN, how to set up and configure. Now I'll probably add another video on how to secure it with IPsec. This will probably just be tunnel protection on the interfaces, on the interface tunnels. But I just really kind of wanted to show the DMVPN part of this and not focus on IPsec. But yeah, if you have any questions, let me know in the comments. I will probably be making phase 2 and phase 3. Phase 3 will probably be pretty short because I won't be starting from scratch. It should just be a couple commands. But if you think this video helped you, like and subscribe, do whatever. I'm really just here to practice networking and hopefully help someone along the way. So thank you.